we're doing the law of cosines given by this formula. The law of cosines. This is only one formula. It's just like that area formula the other day. It's the same formula written 3 times. You do not have to write all 3 of them. It's the same formula, just written 3 different times. Again, shame on them for always using A, B, and C, because on your test it might be BTS, might be CHI, X, Y, Z. So don't fall in love with the letter. But that is the formula. And that's what you need to have in your notes. You may notice the pattern between all of these, though. If you pick up on the pattern, then that's why you don't need all 3. Notice, angle A is the angle we use, and side A is the one over here by itself. Angle B is the one we use, and side B is one by itself. Angle C, side C. Whatever angle you use in the problem, it's that side that's going to go over by itself on the other side of the equal sign. That's the pattern, and the other 2 sides are the sides used for the rest of the formula. So, let's do an example. Anybody need me to leave this on the board? Okay. Today, let me back up. You always want to use law of sines when you can, but who can tell me, what did you need to have in the problem to use law of sines? Justin. That's right, an angle and a side. You need a pair to fill out your proportions. So today, you're not going to be given that pair. You're going to be given pieces of a triangle, but never an angle and a side pairing. That's when you know you need the law of cosines, if you don't have that pair. Can I take this off the board? Okay. Like here, we do not have, you may think this is, you might recognize this. This is a classic law of cosines problem, because even though we have 3 pieces, we do not have a side angle pair, nor do we have a way to get one. So, we need the law of cosine. What is the only angle provided in this problem? A. So which side has to be the side by itself? A. Very good. It's always going to be the side opposite the angle. So here we go. A squared equals B squared plus C squared minus 2BC cosine of A. And it's just that simple. Now, once every few sections I tell you with great regret that there's a mistake that someone's going to make on the test, and every time someone makes it. Here's the mistake people are going to make. First thing they're going to do is they're going to add these, and that's fine. 16 plus 64, that'll give you 80, minus 64 cosine 46. Here's the mistake people are going to make. They're going to do 80 minus 64 times cosine 46. Why can't we do that? Yes, sir. Order of operations, that's right. 64 is married to cosine 46 via multiplication. You cannot use it in subtraction until you've applied everything else. So, you want to do 80 minus the whole quantity. And the easiest way to do that is just in the calculator. Calculator. Make sure you're in degree mode, which I am. Mode, down, down, go over to degree and hit enter. So, 80 minus 64 cosine 46. Are we done?
No.
Very good. Second square root of that answer. 5.96, so it says nearest 10th. So would that be 6 if we round it to the 10th? So A equals 6. Now it does say solve the triangle, so we're still not done. But now that we've got 6, what could we use to finish the problem? Law of sines. You're welcome to use the law of cosines. Actually, I haven't shown you how to do that yet. So yeah, at this point you would have to use the law of sines to figure out the rest of the problem. So here we go. Now, when you start doing the law of sines to find an angle. What did we find out yesterday? There is the rare occasion when you're using the law of sines to find an angle where it'll give you something misleading, right? What won't the law of sines give to you when you're looking for an angle? What won't it ever give you? When it comes to an angle. Who said it? Obtuse. It can't give you an obtuse angle. But there's a way to make sure that you never have to worry about that. If there was going to be an obtuse angle in this picture, which angle would it be? So don't look for C. That's the way that when you have a problem like this, you can avoid that problem altogether. Sometimes you don't have that option to say we're to only give you 3 pieces and make you do it like yesterday. But when you just have to solve a triangle, if you want to avoid that little law of sines, ambiguous case of the law of sines problem, then just avoid the potentially obtuse angle and just find the other one. So let's just look for angle B. Sine 46 over 6 equals sine of B over 4. Do your cross multiplying thing. Okay then, that was way fast. Oh, we're playing the game, right. Dang it, that's actually probably a really good guess. 20, do I go above or below? 7 degrees. I'm going to regret this. I meant 27. Is it not? Are you serious? God, I hate myself. 29 degrees. So if you add and subtract, what will it give you? Question. If you had forgotten that, and if you had done the law of sines to find angle C, what would it have told you it was? If you had done the law of sines to find angle C, what would your calculator have told you it was? What? No. If you had, we'll do it in a second to show you. If you had done, if someone gets this right, I'll take away any problems from your homework. If you had done, no, don't plug it in your calculator. I want this to be a logic thing. If you had done the law of sines to find angle C, what would it have told you it was and why? Chris. It would have told you 75. Why? The supplement, right. Remember what we did yesterday? Every time there were 2 solutions, it would always give you the acute one, which was always supplementary to the one it gave you. You may take any 2 problems off your homework today. Very good. It would have told you this was 75. You may have a word problem in the future. I once gave a nothing but word problems quiz. But there was a problem that looked like this. There was a problem that looked like this. And they had to do the law of sines to find this angle. And it gave them 40 degrees. And almost every single person just put 40 because they trusted their calculator. Could this possibly be 40 degrees? No. If you can tell it's supposed to be an obtuse angle, now this one is kind of hard to see. It could have been right, it could have been slightly less, it could have been slightly greater. But if you ever have a problem like on the ACT where it's obviously obtuse, but using the law of sines gives you something obviously acute, then you're running into that thing we talked about yesterday. So if it told you 40, what would your actual answer be? 140, yeah. So anyway, just something to keep in mind. But again, you shouldn't have to worry about that as long as you just solve for the smallest angle today. Solve for the smallest one, and you won't have that problem. All right, let's try this one. Holly, how am I going to set this up?
You're going to use the law of sometimes T squared equals 4 squared plus 6 squared minus 2 times 4 times 6 plus sine.
Wow, that's pretty flawless right there. Perfect. Because we're using angle C, side C is the one that goes over by itself. So, punch that in your calculator, see what you get. Just remember not to subtract prematurely. Ooh, guessing time. Looks to be significantly bigger than the other angles. I'm going to go with 7.9. Watch it be 8.1. I'm going 7.9. Somebody punch it in and break my heart. In your face. Yes, in your face. Oh, I'm so stupid. It did say to the nearest. No, it didn't. It said to the 10th. You're a liar. You're thinking degree it was the whole number. It was 10th. Of course, I still overshot, which price of right rules means I'm still disqualified. Okay. Now, which angle do you want to solve for? They couldn't. Neither of them can be obtuse, so just pick one. B. Yeah, when in doubt, always go with the smallest one, just in case, but this one couldn't possibly be obtuse because we already have one of those. Sine of 96 over 7.6 equals sine of B over 4. Multiply, divide by 7.6, take sine inverse. Oh, that's your guess. Oh, right. 40, 32. Oh, is it really 31? So really it is 32 when you round to the nearest degree. Yeah. Oh, C. Diddy's on his game today. Oh, right, come back. I'm sorry, I forgot. I knew it was going to happen. Don't worry, we just started a second ago. Because, I mean, not that either of them is going to be. Somebody just chose B. But you want to avoid any potentially obtuse angles because when you do the law of sines, it won't give you an obtuse angle. That's the kind of the whole point of what we did yesterday. When you do inverse sine, it'll always give you something between 0 and 90. That's why. So what's angle A going to be? So, well, they were both 0.5s. Okay. If you're off 1 degree or so, it shouldn't make a big difference. You shouldn't have one on your test that's a 0.5 scenario putting you in that position. Hopefully they'll all be pretty close to darn right even. So if someone put 31 and 53 and someone put 33 and 51-ish, that's fine. Questions? No questions? Well, there's another scenario where you can use the law of cosines, and that is here. That is here. When you have all 3 sides of a triangle and no angles, you can use the law of cosines again. Now, cosine, if you were to look at your unit circle, has no duplicates between 0 and 180. So it'll give you any angle between 0 and 180. So it's not as big a deal when you're using inverse cosine, which angle you look for. But nonetheless, I always like to look at the smallest one. Yeah. Ooh, isosceles. Nothing's going to change, but since 2 of them are the same, it makes sense to look for one of those. That way, yeah. So, which angle do you want to look for? C. So, little c goes over here by himself. C squared equals b squared plus a squared minus 2. I lost my place. 64 equals 100 minus 96. Now again, do not subtract. Well, I mean, don't subtract those two. You have to subtract the 100 first, giving you negative 36 equals negative 96 over cosine C. Divide by negative 96. So you're going to take cosine inverse of 36 over 96, since the negatives canceled, equals Charlie. Ooh, do I have a guess? 64. What was it? 68? 68 degrees, so that would make this 68 degrees. Now normally, you won't have an isosceles triangle, so you won't have 2 angles that are the same. But when you find one, how will you finish it up normally? Rhymes with law of mimes. Law of sine. You have to do law of sines to find one of the angles, and then subtract to find the third one. So 44? Yes, ma'am. We divided it because it's multiplied by cosine C, so we had to divide it. Sure. 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 Oh, you reviewed the steps? So on the last two problems, the angle that we used was predetermined because it gave it to us the problem, right? But here, we don't have any angles, so we just have to pick an angle to choose from. Well, somebody noticed it was isosceles. And since we had to choose the angle, they said, why not choose one of the two angles that are going to be the same? Since normally this is the case. Normally you just pick any angle you want. So let's say we said we want to find angle B, right? Then side B has to be the one over here by itself. And then A and C fill out the rest of the problem. So from here to here, 64. 8 squared plus 6 squared is 100. 2 times 8 times 6 is 96. Now, because this is being multiplied, we can't just subtract these numbers. So we subtracted the 100 over first and got this step. Then we divided by the negative 96 and got that fraction. But then that was equal to cosine of C. So we took cosine of this. Okay, now today, we're going to do another one like that. But today, yes. Whenever you're looking for an angle, it will always be inverse. Angle, inverse. They go together. Today, just like the other day, you're going to have to find the area for all of these. Now, for this one, well, that's pretty much straightforward like our DOM. 1/2 sine of the two sides times, or 1/2 4 times 6 sine 96, right? The two sides and the included angle. Now you could, on your test, I'm going to have at least one area problem, and you're more than welcome to just use that formula for all of them, like this one. Now you couldn't have used the area formula for this right off the bat because you didn't know any of the angles. You would have had to find one using law of cosine. And you're welcome to do that, but on a test, what if all it asks for is the area? Some of you aren't going to want to take the time to use law of cosine to find an angle, then use the formula. So I'm going to show you another area formula for triangles, one that requires all three sides. And it is, it's called Hero's formula. I actually did research on this at one point, but I've forgotten and I no longer remember why it's called Hero's formula. But Hero's formula is the square root of S. Now I'm going to tell you what S is right now, actually. S is nothing but the three sides added together divided by 2. It's S times S minus A times S minus B times S minus C. This, by the way, is called the semi-perimeter. S is known as the semi-perimeter. You add, it's the perimeter divided by 2. And here, no, it's an A. I just don't. My A's have very little backbone. I have spineless A's. What? It's the semi-perimeter. It's S is found by adding the three sides up and dividing by 2. Again, that's Hero's formula. H-E, well, I think I've also seen it called Heron's formula with an N on the end, but Hero just sounds cooler. So here we go. First thing we have to do is find our semi-perimeter. 8 plus 8 plus 6, 18 over 2, so S is 9 for this problem. Again, given by this formula, y'all. Add them up, divide by 2, S is 9. So, Hero, 9 times 9 minus A would be 3. 9 minus 8 would be 1. 9 minus 8 would be 1. So is that the square root of 27? Or 3 radical 3? 3 radical 3? Or you can give it to me as a decimal. What would this be as a decimal? That's the what? You can add, yes. Darn it. Was that why you were asking too, Justin? Well, that changes everything. Yes, it does. So it's 11 times 5 times 3 times 3 now. What was it? Units squared.
So I think this are 11. I think this are 11 plugged into those X's.
All 4 S's, yep.
Okay. The S equals A plus B plus C is also rule A.
Yeah, those are the sides. You don't need angles at all in this formula. That's the beauty of it. That way, if you have a problem on your test that has all 3 sides and asks for the area, you can just jump straight into this formula. In fact, the next one, which I believe is another side, side, side problem, we'll just start with the area and then solve the triangle. Questions about Hero's formula? Okay, let's look at one more. Or 2 more? One more. Yeah. Good question. Most of the time, they just like it as a radical, so I guess that'd be what? Geez, what is that, 45 times 9? I don't even know what that'd be as a big number. Oof, reducing that would be kind of a pain. Although 9 goes into it 55 times. So I guess you could leave that as 3 radical 55. It's up to you, because even on a test, let's say on a test it is in radical form, you know, but you found it as a decimal, just punch in all the radical answers and see which one equals your decimal. So it's up to you. I've always thought area, more than anything, should just be looked at as a decimal. But that's, that's just me. Okay. I want you to find the area and missing angles for this triangle. Area and missing angles for that triangle. And I would have tried, well, never mind. We'll discuss. If you're feeling confident, I can let somebody work it on my board.
I kind of want to try it.
Come on up, Sam. What? Nope. Doesn't matter what area or order you do it in. What?
Let's see. Okay.
Well, actually, that may be different now.
What? Area, I gotta do the area force. Are you serious? I don't care. I'll do something. Alright, area. What was the area? Alright, area. Alright, here we go. Area. Alright. 1/2 B C 3. This is so hard to write on this thing. Sine A.
Finding the area.
I gotta find an area. I can do area first. No.
You just did an area problem.
Oh yeah. Why did I do it that way? Gosh dang it. Alright. Dude, this thing is so hard to figure out how to do.
Are you solving for angle A? You're going now
It's so hard to do. Okay, okay. Alright, let's see. Alright. Area, size. So, 6.5. Dude, this thing's so hard to write on. Like you have no idea. Yeah, dude. Minus A. What, Justin?
I agree with that.
That's weird. 5. Five point three.
How are we looking?
5.3. I think.
Wow, I didn't know you could write big letters.
I know, right?
I'll take that. Thank you.
Cool. I could finish it.
Well, I know,
But I take it.
well, no, well, I just need to. Everybody, I stepped outside. Okay. Can't wait. Will somebody verify 5.3 is the area? Awesome. 5.3 is correct. All right, Nate, what'd you get for angle C?
I don't got the area right now.
Because you're talking about Ultimate Fighting and boxing. Shh. Bridget, what'd you get for angle C? What'd you get for angle A? I did say C. You got 102 for angle C?
Got 32 for C.
Okay. See, C should be the smallest angle since it's opposite the smallest side. So, point of curiosity, how did you set up? Which one did you solve for first? For which angle? Oh, you did 3 squared equals 4 squared plus 3 squared? You used the 3 twice? I think you meant to use the 6 the second time. Yeah, that's probably. So Nate, you got 32.
On these 30.
B is 32. Holly, what'd you get for?
I got 35.
Holly, what'd you get for?
27.
And what'd you get for A?
27.
Okay. Did anybody else get something different than that? Maybe we can diagnose the the problem in our formula or something. I'm sorry. Sure. Okay. Those look to be correct, so you may want to change if someone didn't hear you.
Everything's right. Everything's
Any other questions? All right. Let's see. What was my last slide? Oh, okay. This is nothing more than what we've already done, except it didn't draw you a picture. Only difference. On all of them, they gave you two sides and an angle, or all three sides. Exact same thing as what we just did. But if someone would like to choose one of those, for us to work them out if you wish, you can work any of them you want. 15, because it's a right triangle. 15's fun because you can use anything you want in the entire world to solve it. It is a right triangle with angle B, and we know that the two legs are 5 and 2. So to solve this triangle, you could use Pythagorean theorem and SOHCAHTOA. You could use law of cosine. Let's see, this is A and B. Nope, C. Thank you, yes. Which angle you want to solve for? C. All right, using the law of cosines. Actually, there are so many things you can do here, it hurts. Now, if you wanted to do every other problem on the board, it's funny you asked this one. Every other problem on the board, let's say this would be like 50 degrees or something, and you'll have to do, law of cosine. Little b squared equals a squared plus blah blah squared. Eventually you'll have cosine b. Because it's this one, you could choose to use SOHCAHTOA, and in geometry today I was doing this, so it's kind of hard for me to break out of that when I see a right triangle. But officially in this class, you would solve this by doing this. B squared minus 2 equals, thank you, 5 squared plus 2 squared minus 2 times 5 times 2 cosine of 90. However, cosine of 90 is just what? Sine of 90 is 1. Cosine of 90 is 0, which means all this being multiplied by cosine of 90 is just 0. Aww. It's just 0, which hopefully you can kind of see where the law of cosines originated from the Pythagorean theorem, and then they just used the trig identity. So, because that's just going to be 0, you end up getting b is the square root of 29, and you could use the law of sines, you could use SOHCAHTOA, you could use whatever you wanted to finish up the problem. That was an interesting one. My mind kind of went into overload because there's so many things we could do. Does someone have a further question on that problem or a question on a different problem? 20? All right.
So I'm not telling you from the side.
No, you have to find all of it.
Oh, okay.
But from there, you would have to do law of signs, or you could use SOHCAHTOA. It's up to you. 20 is going to end up working out very, very similar to this one. It's just all three sides. 4, 7, 6. But to draw that, it was 4, 7, and 6. I don't really worry about the letters right now because it's kind of a mute point. I'm sure it's not obtuse, but the only problem with drawing your own triangle is you then fall in love with that drawing. Like, ooh, it has an obtuse angle. Well, no, it doesn't. I just made up that drawing. You have to remember that when you draw it, you may be drawing it not to scale. So if you choose to draw it, ye be warned. So, which angle do you want to start from? The 4 angle, 6 angle, or 7 angle? The 7, huh? You like to look for the biggest one, don't you? Okay. Fine. We can do that. 7 squared equals 4 squared plus 6 squared minus 2 times 4 times 6 cosine inverse, or cosine of, I guess we have to label this. What was the 7? 7 was the B. Cosine of B. 49. 16 plus 36 is 52. Hey, this is very similar to the last one we did. And I saw people doing the cardinal sin of the law of cosines and subtracting right here. Subtract the negative 52 first. Then divide by the negative 48. So it's 3 over 48 equals cosine of B because the negatives canceled. Inverse cosine of that. And what is it? Was it 86? And then you'd use the law of sines to finish it up. Just like the other day, I'm going to want you to find the area for every problem as well. So, was there questions on the area portion? You'll either have to use the 1/2 BC sine A formula. Again, don't fall in love with the letters, it's just random. Or Hero's formula, one of the two. Either the Dom formula or the formula I taught you today. Here you go. Oh, let me write it in here. The direction, yes, the directions say just to solve the triangle, and I'm adding and area. Ooh, a nice swampy green.